Welcome to Balaiah Math Lectures. Learn every step. Today we are going to learn the continuation of the concept normal form. Here you will find the non-singular matrices P and Q such that your PAQ is in normal form. That means you have to write the given matrix A in the form of IAI. Here you can see that this is the matrix which is given of order 3 by 3. Now you will write A is equal to I3 because the number of rows in this matrix is 3 and the number of columns are also 3. Then you will reduce this matrix A into normal form by applying elementary row and column operations. Now we will apply the same row operations on prefactor of RHS and we will apply the same column operations whatever applying on the matrix on the left hand side must be applied on the post factor of RHS. This is the way what we are going to do. 1, 1, 2, 1, 2, 3, 0, minus 1, minus 1. This is your given matrix. That is equal to I3 1 0 0 0 1 0 0 0 1 into A. You should not write the matrix A here again because you are applying the elementary operations on left hand side matrix and the same operations while applying the elementary row operations and column operations to reduce this matrix, the same row operation should be applied on the prefactor and the same column operations must be applied on the post factor, which is 1 0 0 0 1 0 0 0 1. Now how can you reduce this one into normal form? Use this element and make this element as 0. That means R2 tends to R2 minus R1. So your matrix is no change in first row 1 1 2 1 minus 1 0 2 minus 1 1 3 minus 2 1. No change in the third row. That means 0 minus 1 minus 1. That is equal to no change in the first row 1 0 0 R2 minus R1 R2 minus R1 minus 1 1 minus 0 0 minus 0 0 0 1 into no change in the post factor, so it is as it is. You need to apply the elementary column operations and make these two elements as 0. So let us apply the elementary column operations. That means C2 tends to C2 minus C1 and C3 tends to C3 minus 2C1. Then this will be 0. That means no change in first column, which is 1 0 0 1 minus 1 0 1 minus 0 1 minus 1 minus 0 minus 1 2 minus 2 0 1 minus 0 minus 1 minus 0 means 1 minus 1. That is equal to no change in the prefactor because you have applied elementary column operations, so that no change in prefactor. 1 0 0 minus 1 1 0 0 0 1 into A into the same column operations must be applied on the post factor. No change in the first column 1 0 0 C2 minus C1 0 minus 1 minus 1 1 minus 0 1 0 minus 0 0 and C3 tends to C3 minus 2C1 C3 minus 2C1 minus 2 0 minus 0 0 1 minus 0 1. To use this element and make this one as 0. That means R3 tends to R3 plus R2. Then this is no change in first two rows 1 0 0 0 1 1 0 minus 1 plus 1 0 minus 1 plus 1 0 is equal to the same row operation should be applied on the prefactor. That means no change in first two rows 1 0 0 minus 1 1 0 R3 plus R2 0 minus 1 minus 1 0 plus 1 1 1 plus 0 1 and no change in the post factor. It's 1 minus 1 minus 2 0 1 0 0 0 1. Now use this element and make this one as 0. C3 tends to C3 minus C2. By applying this one, you have 1 0 0 0 1 0 0 0 0 is equal to no change in the prefactor A into no change in the first two columns 1 0 0 minus 1 1 0 C3 minus C2 C3 minus C2 minus 2 plus 1 minus 1 0 minus 1 minus 1 1 minus 0 1. What is this? I2 0 0 0 is equal to PAQ. Your P is this one and Q is this one, which is in normal form, and the rank of the matrix is 2. Your non-singular matrices P and Q are P is this one and Q is this one. This is the way how to find non-singular matrices P and Q by reducing the given matrix into normal form. Let us solve one more problem. Your given matrix is this one, and you can observe that the order of this matrix is 3 rows and 4 columns, which is 3 by 4. So first of all, you need to write this one as IAI form. Right? A is equal to IAI, but this is called prefactor and this is called postfactor. You have to take this identity matrix to the number of rows of the matrix A. How many number of rows are there? 3. So you need to take this is as I3 and this one as I4, because the number of columns in A is 4. So that you have to take the identity matrix of order 4 here. So let us write the matrix on the left hand side, which is, and on RHS let us write. Now let us reduce this one into normal form by applying elementary row and column operations. While applying elementary row operations on this matrix, the same row operation should be applied on the prefactor of RHS. While applying the column operations on this matrix, the same column operation should be applied on the postfactor. Then you can obtain the non-singular matrices P and Q such that your PAQ will go to normal form. This is the way what we are following. So let us make these two elements as 0 by putting this one. That means R2 tends to R2 plus R1 and R3 tends to R3 plus 2R1. Apply these two operations, then you will get no change in first row. 1 minus 2 3 4 minus 1 plus 1 0 R2 plus R1 2 minus 2 0 again 7 plus 3 10 6 plus 4 10 R3 plus 2R1 minus 2 plus 2 0 4 minus 4 once again 0 minus 1 2 3s are 6 6 minus 1 5 and minus 3 4 2s are 8 8 minus 3 5. Now the same row operation should be applied on prefactor of RHS. No change in first row 1 0 0 R2 plus R1 R2 plus R1 1 R2 plus R1 1 R2 plus R1 0 and R3 plus 2R1 R3 plus 2R1 2 0 1 and no change in the post factor. That means 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. Now use the same element and make these three elements as 0 immediately. Okay, that means C2 tends to C2 plus 2C1. Multiply this one with 2 and add to this one. And C3 tends to C3 minus 3C1. Multiply this one with 3 and subtract from this column. And C4 tends to C4 minus 4C1. By applying these column operations on the matrix which is on left hand side. No change in first column and minus 2 plus 2 0 0 plus 0 0 0 3 minus 3 0 10 minus 0 10 5 minus 0 5 and 4 minus 4 0 10 minus 0 10 5 minus 0. That equal to there is no change in the prefactor into A into there is no change in the first column, so 1 0 0 0 and C2 tends to C2 plus 2C1. C2 plus 2C1. 2, 1, 0, 0. And C3 minus 3C1. Minus 3, 0, 1, 0. And C4 tends to C4 minus 4C1. Minus 4, 0, 0, 1. Actually, this element should be non-zero. But here it is the 0 column. So let us take this one to last column. C2, if and only if C4. Then it becomes 1, 0, 0, 0, 10, 5 and 0, 10, 5 and the last column becomes zeros. That means, and no change in the prefactor. That means into A into C2, C4 must be interchanging. That means no change in the first column. So 1, 0, 0, 0. Last column should be in second column. Minus 4, 0, 0, 1. Minus 4, 0, 0, 1. And no change in the third column. Minus 3, 0, 1, 0. And second column should be in the last one. 2, 1, 0, 0. Now, use this element and make this one as 0. That means R3 tends to 2R3 minus R2. 2R3 minus R2, which means no change in first two rows. 1, 0, 0, 0, 0, 10, 10, 0, 0, 0, 0, 0. Because 2 5s are 10, 10 minus 10, 0. 10 minus 10, 0 is equal to no change in the first two rows. 0, 1, 0, 0, 1, 1, 0. 2 or 3, 4, minus 1. 3, 2 into 0, 0, minus 1. 2 minus 0. And no change in the post factor. Into A into. Use the same element and make this one as 0. Which means C3 tends to C3 minus C2. Then this will becomes 1, 0, 0, 0, 10, 0, 0, 0, 0, 0, 0, 0 is equal to no change in the prefactor. 1, 0, 0, 1, 1, 0, 3 minus 1, 2 into A into C2, C3 minus C2. So, no change in first two columns. 1, 0, 0, minus 4, 0, 0, 1, C3 minus C2, C3 minus C2, minus 3 plus 4, 1, 0, 1 minus 0, 0 minus 1, which is minus 1. No change in the fourth column, 2, 1, 0, 0. Now, divide this element with 10. That means either row operation or column operation can be applied. While applying the row operation, you should be applied on prefactor. If you are applying column operation, the same operation should be applied on post factor. So I am taking row operation. R2 tends to R2 by 10. Then this will becomes 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0 is equal to 1, 0, 0, 0.1, 0.1, 0, 3 minus 1, 2 into A into 1, 0, 0, 0, minus 4, 0, 0, 1, 1, 0, 1 minus 1, 2, 1, 0, 0. So, this is in normal form. I2, 0, 0, 0. I2, 0, 0, 0. Which is in PAQ form. Where P is this one and Q is that one. Okay. This is the way how to find your non-singular matrices P and Q such that your PAQ is in normal form. I request all of you, please like, share, comment and subscribe my channel Balaiah Math Lectures.